Good morning, girls. Today we will continue our chapter Heat Transfer. On the last and previous videos, we have seen thermal expansion in solids. Right? As solids have definite shape and volume, they expand linearly, superficially, and cubically. That means the change in or expansion in length, area, and volume, all the three takes place in solids. But as liquids does not possess a definite shape, so neither linear expansion nor superficial expansion has any relevance in the case of a liquid, right? Only the volume of a liquid can change, so only cubical expansion takes place in liquids, right? So like solids, liquids also usually expand on heating. Liquids expand much more than the solid when heated, right? As the intermolecular forces between the molecules are not so strong, so they get more, they expand more as compared to solids. Liquid do not have a definite shape, but they have a definite volume, so only cubical expansion takes place. And in solids, linear, superficial, and cubical, all the three takes place. Now, exception we have water, right? Water contract on heating and expand on cooling between 0 degrees Celsius to 4 degrees Celsius. And after that, it will show normal behavior that on heating after 4 degrees Celsius, it will again start expanding, and before 0 degrees Celsius, again it will start contracting. Right? So, between this interval 0 degree to 4 degrees Celsius, water shows different behavior than usual. Therefore, this is called the anomalous behavior of water. Now, the cubical expansion of a liquid on being heated can be demonstrated by the following simple experiment. What you have to do, take an empty bottle with a tight fitting cork having a hole drilled in it middle, a drinking straw, right, two bricks, a wire gauze, and a burner. Fill the bottle completely with water and add few drops of ink in it so that you can notice the rise in level of water or any liquid. We are adding drop of ink to it to make the observations clear. Right? You will easily notice the change in the level of liquid if it is colored. Fix the cork in the mouth of the bottle and pass the drinking straw through the cork. Put some molten wax around the hole so no leakage of water is there, no vapors escape out from the bottle. So, correct measurement of expansion in liquid takes place. Pour some more water into the drinking straw so that water level in the straw can be seen. Now you can mark the water level in the straw. Right? Place the bottle on the wire gauze kept over the two bricks. That means you have to heat it. Heat this container containing water. Right? Then what will happen? Will the level of water in the container increase or will it decrease? It is heating, right? Vapors will form, but they are not going out of the bottle as the cork is there and molten wax is there. So the vapors are not escaping out, they remain inside the bottle only, nothing is going out, right? So, will the water level rise? What do you think? Yes, it will rise. Expansion in the level of water will take place. Now look at the level of water in the straw. You will notice that as the water is heated more and more, the level of water in the drinking straw rises. That means water expand on heating, or we can say liquids expand on heating. Now, when a liquid contained in a vessel is heated, first the vessel will get the heat, so it will expand, due to which the level of liquid will fall. As you know, a liquid cannot be heated directly. It can be heated only by heating the container in which it is placed. Right? It takes the shape of the container in which it is placed. And therefore, we need a container. So, when the container is heated, it expands first and a level of liquid in the container falls. Gradually, the liquid also get heated and expand. The level of the liquid in the vessel also rises. So, real expansion of the liquid is equal to the expansion of the vessel and the expansion of the liquid, what we are seeing, what we are observing. Right? So, the real expansion of the liquid is more than the observed expansion. So, real expansion is equals to expansion of vessel plus the observed expansion of the liquid. Now, explanation of thermal expansion of liquid by molecular motion. Molecular motion, again, molecules are moving freely in liquid, moving anywhere within the liquid. Now, when it is heated, kinetic energy of the molecules increases. As a result, the molecules begin to move more vigorously and thereby increasing the intermolecular separation between them. And we say that the expansion in liquid has taken place. Does the liquid expand on heating? Now, factors affecting the cubical expansion, as you know, right? Cubical expansion depends on volume of the liquid. So, first factor is original volume of the liquid, and another is rise in temperature. More the rise in temperature, more is the expansion in liquid, in the level of liquid. Next is the nature of liquid. Nature of liquid, different liquids have different coefficient of expansion, cubical coefficient of expansion. So according to that, the expansion in liquid takes place. Now, to write it mathematically, we have, if V naught or V0 is the volume of liquid at 0 degrees Celsius and Vt is the volume of liquid at T degrees Celsius, then increase in volume of liquid is given by, increase will given by the difference V0 and Vt. The difference between the two will give you the difference in volume, or the increase in volume, or the expansion of liquid. Now, Vt minus V0 depends on three factors: original volume, that is V0, nature of the liquid, that is denoted by gamma, and T, that is the increase in temperature. Now, different liquids have different cubical expansion. This is shown by an experiment, right? By this activity. Take four identical glass bottles, each fitted with a narrow glass tube up to the same level with different liquids. Liquids are different. The volume of all the liquid is same. The temperature that is provided to all of them is same. So everything is same. The volume is same. The temperature is same, right? But the nature of the liquid is different. They have different cubical expansion coefficients, right? So let's see what liquids they have taken: water, kerosene, alcohol, and benzene. Now we have placed them in a common water bath so that each of the liquid will get the same temperature, right? Same heat. After some time, you will notice that different liquids rise to different level. Benzene expand the most, then alcohol and kerosene. Water expand the least. So it is showing that benzene has highest cubical uh, coefficient of expansion. then alcohol, then kerosene, and water, right? So here coefficient of cubical expansion of some liquids are given. No need to learn them, right? But this is to give an idea that different liquids have different nature, right? Some expand more and some expand less than the other. Water does not have a fixed coefficient of cubical expansion. Its value rises with rise in temperature. Now, application of thermal expansion of liquids in daily life is working of a mercury thermometer. We have read that mercury thermometer consists of a capillary tube with one end closed and a cylindrical bulb at the other end. The bulb is filled with mercury. Mercury is a shiny liquid, and when we put that bulb of the thermometer inside our mouth, or it comes in contact with a hot body, due to this heat, mercury expand, right? As you have seen here, that mercury is having 1.8 coefficient of cubical expansion. It expands, right, when it is heated, and it will reach to the level of mercury rises in the capillary tube, gives us the reading of the body temperature. For each degree rise in temperature, mercury expand by the same value. So the collaboration of thermometer become easier, right? For each degree rise, same volume is increased. Therefore, we use mercury in thermometer as it rises or expand by the same volume for each degree rise. Now, thermal expansion in gases. As in the case of a liquid, linear expansion and superficial expansion are not relevant. In the case of gas also, these two are not having any relevance. Thus, we are concerned only with the volume expansion of a gas. Gases also expand, and when they are heated, gases expand much more than liquids and solids. Right? Like liquids, gases do not have a definite shape, so they also have only the cubical expansion. They do not have a fixed volume also, but they have some volume and they expand accordingly. Take an empty bottle. Actually, the empty bottle contains air. Attach a balloon to it. Right? Place the bottle in water bath containing water, which heats the air contained in the bottle. After some time, you will notice that the balloon gets inflated as shown in the figure. Right? You can see the figure here. Empty bottle containing air, deflated balloon, right? When it is kept in the water bath, that means heating, heat is provided, then due to this heating of air expands and inflate the balloon. This proves that air expand on heating, and this shows gases expand on heating. A gas is heated by keeping either its volume or pressure constant. In both cases, the expansion is same. Right? Either volume constant or pressure constant. Explanation of thermal expansion, again molecular motion of molecules, right, are there, and when they are heated, average kinetic energy increases and they start moving more vigorously or moving violently. As a result, separation between the molecules increases, so they expand. Now, variation of density with temperature. As the temperature increases, density of a substance decreases. Right? When a substance is heated, its volume increases while its mass remains same. Therefore, the density of a substance decreases with the increase in temperature because expansion is taking place, but the mass, number of molecules are remaining same. So volume is increasing, expansion means increase in volume, and density is mass upon volume. Mass is constant, volume is increasing, and volume is coming in the denominator. If the denominator is increasing, the whole fraction will decrease, right? Therefore the density decrease. In case of solids, when temperature increases, increase in volume is very small, and therefore the decrease in density is not appreciable. But in case of liquid and gases, it is significant. As the temperature increases, volume increases by the significant amount, appreciable amount, and therefore decrease in their density is quite considerable. But again, we have exceptions, right? Water contract on heating from 0 to 4. So the density of water increases on heating it from 0 to 4 degrees Celsius, and on further heating above 4 degree, again it will start expanding. So the density of water decreases, but at 4 degrees Celsius it has maximum density, and it is equals to 1000 kg per meter cube or 1 gram per centimeter cube. 0 to 4, when it is heated, it is contracting, right? Anomalous behavior is shown by water, no? So it is contracting, and contracting means the density is decreasing, decreasing till 4 degrees Celsius. So it has maximum density at 4 degrees Celsius, because after that it will again start increasing, again start expanding, right? Let's see this. Do you know, if an iron washer as shown in figure is heated, its mass will remain unchanged? Mass remain unchanged, internal diameter increases, external diameter increases, right? Its volume will increase, but its density will decrease. As the expansion is taking place, mass remaining same, density decreases, internal external diameter and overall volume is increasing.